absolute value equations and inequalities are pretty easy to resolve if you just think about them in the right way. One interpretation of the absolute value bars means to drop the absolute value bars and make whatever's on the inside positive. So, for example, if it's not positive already. So, for example, if we have, say, if we have absolute value of negative 20, that's going to be 20, right? If it's negative, you just make it positive. And if you start out with a positive number, say absolute value of 10, you just drop the absolute value bars and write 10. That's all it is. Now this is pretty easy, right? If I put absolute value bars around any number, you know what it's going to work out to be. If I say absolute minus 5, you know that the answer is going to be 5. And if I say what is the absolute value of 2, you know that the answer is going to be 2. Now this is pretty helpful for us because you'll notice that for every number over here that gives us 20, or for every number on this side that gives us an answer, there's another number on this side that will also give us that same answer. So there are two numbers that have an absolute value of 20. One is minus 20, and the other is its opposite, right? 20. So had I put this or this into the absolute value bars, 20 would have come out in both cases. Similarly, for absolute minus 10 will give you 10, and absolute minus 5 is 5, and also absolute 5 is 5, and so on and so on. So absolute minus 2 is also 2. This is crucial for us, okay? This says that whenever we have an absolute value, the absolute value of something, whenever that, if I want to solve this equation, say, absolute value of x is 10, that means that there are always two numbers that are going to give me, that are going to solve that equation. There are two numbers that I can always plug in for x that will make this statement true. Namely, whatever this number is and its opposite. And that's how all of these things go, right? You have to think, you have to associate two different things in your head whenever you see an absolute value in equality. So the way to solve this, if we were starting from scratch, would be when you're confronted with this, you simply say, you drop the absolute value bars and just say x must equal either 10 or x must equal minus 10. And that's the way to resolve it. All right? Drop the absolute value and turn it into two separate equations. And that'll solve them all, provided that this number over here is positive. If it's negative, then it's not going to have any solution because absolute value says to make it positive, right? An equation like this, absolute x is minus 4, doesn't have any solution because this says that you have to make the inside, this must be, the output of this must be some positive quantity. The only other exception is if you have the absolute value of something equals 0 itself, and you only get one answer for that. The only answer for this is x equals 0. But in most cases, you'll have the absolute value of something equals some positive number, and in that case, the way that you resolve that is drop the bars and set x equal to both whatever that number is and its opposite. Another way to think about absolute value is when you see this notation, absolute x, you should think of this as x's distance from 0. The distance that x is from 0 on a number line. So this is just a different way of thinking about it, but it's particularly useful in solving equations and inequalities. So if I have the equation absolute x, the absolute value of something equals, say, 5, what you should think about when you see this is you should see a number line in your head with 0 in the middle. And this is asking a question. It's saying what numbers are at a distance of 5 from 0. It's always about from 0. So if you look at it that way, it should be obvious that there are, again, going to be two different answers because there are only two numbers that are at a set that are 5 units away from 0, right? and those numbers are -5 and 5. So once again, you see yourself with, when you have absolute x equals some number, say, I don't know, 20, your mind should shift to a number line and think zeros here. So which numbers are at a distance of 20 from 0? Well, clearly that's going to be 20 units this way, 20, and 20 units the other way, so -20. And the answers will be either x equals 20 or -20. So two different ways of looking at the same thing. You'll get answers both ways. Now, this is particularly useful when we're doing not absolute value equations, but inequalities. All right, this distance from 0 concept is something that's going to be important, because what if I have, now if we have this, if I have absolute x is, say, less than 5, not or less than or equal to 5. So this is asking me, first you have to understand what it's asking. It's asking for every number that is at a distance less than 5 from 0. All right, a distance from 0 less than 5. So here's 0, and the numbers that are equal to a distance of 5 are, of course, -5 and 5. So I write those down. So this is asking for, which numbers are closer to 0 than are at a lesser distance than 5 from 0. So this should call to mind that there are many numbers that solve this inequality, because there are many such numbers that are closer to 0 than these two numbers, namely everything in between here. All right, if you plug any one of these numbers in to this absolute value inequality, you will get a true statement, right? If I go with -4, absolute of -4 is 4, which -4 solves this inequality, hence it counts as a solution. Similarly for -3, -2, -1, 0, 1, 2, 3, 4, and 5. All these numbers make it a true statement. Therefore, all of these numbers constitute the solution of this. So the way that we do this is, when we see absolute of a number, the absolute value of something is less than or equal to, say, I'll go with 5 again. The way that we should interpret that is with the number line, and you say that the values of x that constitute the solution to this, the numbers that work, the numbers that make this a true statement, are all the numbers between 5 and its opposites, everything in here. The way that we say that is, to say the word between in math, is that we use two of the same inequality symbols. This translates to this in your head, which should translate into drop the absolute value bars and say x, whatever the argument is, has to be between 5 and its opposite. And that's what the solution is. All right, that's how it goes whenever it's a less than. If it's a less than, absolute value is less than something, you always want that something to be sandwiched between this number and whatever its opposite is, and they all go that way. So for example, if I say absolute x is less than 15, again, you should think, oh, this is asking me for all numbers who are less than 15 units away from 0, right? Numbers that are less than 15 units away from 0. So, number line, 0, here's 15, here's its opposite. Alright, the numbers that are equal to 15 units away, we only want the numbers in between. So we jump right to the solution by saying x has to be all numbers between 15 and its opposite. And that is the way to solve absolute value less than inequalities. The greater than inequalities are extremely similar. If I say absolute x is greater than or equal to 5, say. Now this is asking for all the numbers on the number line that are at least 5 units away from 0. Right? Which numbers have an absolute value greater than 5? Which numbers are more than 5 units away from 0? So it's all about it starts with the numbers that are equal to 5 units away from 0, and that's the 5 and the minus 5. And the numbers that are going to satisfy this are out here and out here, right? 6, 7, 8, 9, 10. All of these numbers in here have an absolute value greater than 5 because they're more than 5 units away from 0. Same for over here, minus 6, minus 7, minus 8, minus 9. Everything out here has an absolute value. All these numbers have an absolute value greater than or equal to 5. So the way that you want to do this is, if it's greater than, you want the numbers that are going to constitute the solution to be either greater than or equal to 5, or x has to be less than or equal to its opposite, minus 5. Right? See how it's just like the opposite of this one here, right? It's sort of like the complement. Less than or equal to is everything between. Greater than or equal to is everything beyond. But this is how it goes, right? Whenever you have it's a greater than, you must split it into two different things. There's no way to sort of sandwich it into one expression like we could with this one or this one. Because they come in two distinct sets, you must break it into two different pieces. But if you realize that that's the way it works, it becomes pretty easy. Because I could give a problem like, if I said absolute x is greater than 100, you would have to think, first you have to interpret this as numbers that are more than 100 units away from 0. More than 100 units away from 0. So you think in your head here, 0 minus 100 and 100, that's what it's all about. Which numbers are going to satisfy that definition of being further away, and that would be numbers outside here or numbers outside there. And so you would take this, break it into two different pieces, and say x must be either greater than 100 or x must be less than minus 100. And that's what the solution set is. If you have absolute x equals some positive number, the way that you solve that is to say x equals either that number or x equals the opposite of that number, whatever it may be. If you have absolute x is, say, less than some positive number, what you do is you get rid of the is you say x must be between that number and its opposite. And the third case is if you have x, absolute x is greater than some positive number, you must say that either x must be greater than that number itself or x must be less than its opposite. So these are basically the only three things that you'll ever see with absolute value. In each case, right, we sort of, to resolve it, we always drop the absolute value bars and we come up with some different expression that we should be able to solve using other methods. Now, the reason that I've been using x in all these examples is because what's on the inside here doesn't really matter. All right? I've been using x, but it doesn't matter. To get rid of the absolute value bars, you treat everything as though it's exactly the same as these examples here. For example, if you have something more complicated, like, say, x minus 5 over 2, absolute, equals 3. You should recognize this as really being no different than, this is pretty much the same problem as absolute x equals 3. Because it's just absolute something equals 3. It's equal to some number. How do we solve this? We set whatever this is equal to this and its opposite. So that's what we're going to do here. To get around the absolute value bars, to resolve them, no matter what's in here, you always say, oh, that expression either has to equal 3 or that expression has to equal its opposite. And when you solve these equations, those will be the solutions of the original. So let me do that real quick. You just multiply by 2 and get 6, and then you add 5 and you'll get 11. So in this case, x equals 11. And again, you multiply the minus 3 by 2 and get minus 6, and then you add 5, and then you get x equals minus 1. And that's how it's done. From here to here is just resolving the absolute value. That's the whole point of this video, is just to get you from here to this step. From here on, you have to be able to solve the resulting equations with other methods, but just getting rid of the absolute value should be a piece of cake. A quick check will show that these numbers are, in fact, the answers, right? Because you can plug them in. 11 minus 5 is 6, divided by 2 is 3. Minus 1 minus 5 is minus 6, divided by 2 is minus 3, but absolute minus 3 is 3, so both of these work out. Similarly, if you have one of the inequalities, right? If you have the absolute value of whatever is less than some number, you just drop the absolute value bars, sandwich it in between these things, and you're ready to go. For example, if you have absolute, say, x minus 2 over 4 is less than, say, 12. All that you have to do, you should recognize this as an absolute value that is less than, and sort of ignore the fact that there's a complicated expression inside here, and just drop the absolute value bars, x minus 2 over 4, and sandwich it between 12 and its opposite. That's all that you got to do, and then solve it from here, right? Multiply all three sides, or all three pieces, by 4 to cancel that out. You get minus 48. Must be less than x minus 2, which must be less than 48, and then you just add 2, so you'll get minus 46 is less than x is less than 50. And that's the way that you go. You can be certain that if x is between these two numbers here, then the resulting expression will have an absolute value between minus 12 and 12, which is exactly what you wanted. So you had to use 2 pieces for that. And the last one I have is a little bit more complicated, just a bit. But if you have something, let's say 2 minus 4 times absolute x minus 1 is less than, say, 6. What would you do about this? You would first, you'd have to work your way to the absolute value expression. You would want to turn it into, somehow play with this expression and get it into one of these original forms, right? Isolate the absolute value and come up with just one inequality or equation. So in this case, working towards isolating the absolute value is no different than isolating the x in this case, for x is less than 6, right? These two are pretty much solved the same exact way. In both cases, you're going to subtract 2 and then divide by the negative 4, right? There's no way to like combine these two or anything. You must take away 2 and then divide by the minus 4. So let's do that, and we'll have, if you subtract 2, you'll have minus 4, absolute x minus 1, which is what we're after, is less than 4. Right? Then you divide both sides by minus 4, and you'll get absolute x minus 1. You got to switch to the sign because you're dividing by a negative, is greater than minus 1. And then at this stage, look at what you have. You got to use a little bit of common sense here. You have the absolute value of some expression is greater than negative 1. When you see that, you can just recall that the output of an absolute value is always going to be at least 0. Right? It's got to be some positive thing, if not 0. It's some distance from 0. So at this point, we could just say, we're free to say all real numbers, because anything that we substitute in for x is going to make this statement true, which means that anything that we substitute in for x in the original must also be true. Now, why is that so? Because, check it out, you have 2 minus 4 times something that must be positive. So this, on the left side of the inequality, you're you start with 2 and you're taking away a positive quantity guaranteed, and you want that to be less than 6. Well, since you're starting out already less than 6, the final result has to be less than 6, right? Because it's 2 minus something that must be positive. So it's clear sort of from the beginning that there is that the solution set is all real numbers. You could plug anything in for that one. One last example, just to have a legit one that's a greater than, is if we had, say, 2x minus 4 absolute is greater than 10, greater than or equal to 10. So first thing that you notice is that its absolute value of something is greater than 10, so you want the inside expression to be at least 10 units away from 0. So you have to break it into 2 different pieces. You'd say you want 2x minus 4, that expression must be greater than or equal to 10 itself, or if I can fit all this, or you want 2x minus 4 to be less than its opposite. And this is how you get rid of the absolute value, right? It turns into these 2 things, and you just have to solve these. It always breaks into 2. So in each case, we'll add 4 to both sides and then divide by 2. So 10 plus 4 is 14, divided by 2 is 7. So x must be greater than or equal to 7. Or x must be, when you add 4, you'll get minus 6 divided by 2. X is less than minus 3, and the solution set that we get for this is or equal to, the solution set that we get for this is x either has to be less than or equal to minus 3, or x is greater than or equal to 7. And that's the way that you solve all absolute value inequalities, no matter what's on the inside or outside. They can all be broken down to one of the 3 basic forms, right? Absolute something is equal to, absolute is less than, or absolute is greater to. And the way that we resolve the absolute value, the way that we get rid of that, is to jump from this line to down to this second set of lines here, depending on what the situation is. And that's pretty much all there is to it.